Empirical provide compelling, interactive learning across a range of delivery options. Live on site, live online, or online anytime, we have a training course that is ideal for you. For a no-obligations chat about your training requirements, contact us at empirical.com.
In this session, we're going to discuss HSPA plus data delivery. So looking how IP datagrams get from the radio network controller to the mobile and vice versa. In order to do that, we need to focus on two key areas. One will be the downlink HSPA plus frame protocol, and the other being the uplink HSPA plus frame protocol. So if we had a network, assuming that the radio bearer has already been put in place using radio bearer setups and reconfiguration, the RABs in place between the radio network controller and the mobile, as an IP datagram comes into the system at the serving GPRS support node, it will be forwarded down towards the radio network controller. When it gets there, we're going to use a combination of frame protocols across the IUB interface and the HSPA plus resources across the air interface to deliver that packet. So we need to look at these frame protocols in a bit more detail. So here's the same example. We've got a radio network controller, node B and a mobile. We can see that on the RNC and the mobile we have some key protocols. Now it's these key protocols that we need to think about the data delivery. So the IP datagram is coming in across the RNC. The RNC isn't actually reading that IP datagram, and it's going to be delivered ideally towards the mobile. The layer below for IP delivery is PDCP, Packet Data Convergence Protocol. So that's what's dealing with the compression of the packet if required. Below that we have reliability, possibly RLC, radio link control. This can either be in an unacknowledged or an acknowledged mode for IP datagrams. Sitting below that we'll find MACD, the dedicated version of MAC. So this is what we would traditionally use for circuit switch voice services and normal packet switch data before HSDPA came along. So that needs to deliver information down towards the node B. And how do we get information down to the node B? We use a frame protocol. So this is not HSPA yet, this is just standard operation. So MACD goes into a framing protocol, into the physical layer, across the IUB interface, and we're now at the node B. When we hit the node B, we then can map whatever's in that framing protocol over the air interface, effectively the physical link. So the dedicated channels, for example. If we think about HSPA plus, we need to upgrade the system. Now in the downlink, we're going to effectively change that framing protocol to a high-speed downlink shared channel framing protocol. So that's now going to say we're dealing with HSDPA resources. And the air interface is going to change. We're now going to include another MAC layer, the MAC HS or EHS, depending on whether you're using flexible RLC options. We'll also have an upgraded physical layer, which is all about the new spreading factor 16 codes and the mechanics associated with downlink HSPA plus operation. So you can see we've added a framing protocol, a high-speed downlink shared channel framing protocol. Specifically, there's three types. There's the original format when we introduced HSDPA, but we have two other formats. Type 2 supports flexible RLC. So where the RLC isn't doing the segmentation, it's sending the information down towards the node B, and it's the MAC HS and EHS layers which are doing this flexible segmentation, specifically the MAC EHS. Type 3 is when we introduced enhanced cell FAT, so using HSDPA resources effectively whilst in the cell PCH and URA PCH states. In the uplink, we have obviously the EDCH, so we've got the enhancements associated around the EDCH, enhanced uplink operation. And specifically at the MAC layer, we had MAC ES or IS, depending on whether we're introducing the uplink flexible RLC operation. So similar diagram between the mobile going up now towards the RNC, packets of data. Ultimately, we have a MAC layer called MAC ES or IS, and that goes between the mobile and the radio network controller. Sitting below that, the MAC E, MAC I layer, and below that, the physical layer. So packets are delivered up towards the node B. When they get to the node B, these MAC-E, MAC-I frames are effectively put in, the data's put into a framing protocol. And as you can see, we have a EDCH framing protocol. Now, irrespective whether using the MAC-E or the MAC-I approach, the flexible RLC offering, you'll find that the EDCH framing protocol can support both. So there's only effectively one type of EDCH framing protocol. So in summary, we've identified the delivery of data. We've identified the key mechanism to go between an RNC and a node B is called a framing protocol. And in the downlink, we have a high-speed downlink shared channel framing protocol. 3 types: the normal, the one that supports flexible RLC, and the one that supports the enhanced self-fetch state. And in the uplink, we have a EDCH framing protocol, and that supports both the MAC-E and the MAC-I flavors of uplink EDCH.
Need to know more? Why not visit our store, where you can choose from over 200 hours of video-based training. Alternatively, you can contact us to discuss any specific training requirements you may have.